The other thing we're going to take a look at today is finding the second derivative in terms of t. So we know how to take the first derivative, and that's basically the first two steps in this process. Find dx dt, dy dt, then dy dx. We figure that out by taking dy dt divided by dx dt. So that's what we've been doing so far to find the first derivative. Second derivative, where it gets a little bit more complicated. We have to take the derivative of dy dx. So the derivative we've already found, we take its derivative. That gives us the second derivative. Key part is what's in the parentheses here. In this step, you're taking the derivative in terms of x, right? So the second derivative we're doing in terms of x. So we need to use implicit differentiation because the derivative that we're going to have is actually in terms of t. So as we take the derivative, we have to multiply by dt dx. So that's a little bit different from before, and we'll take a look at that in a second. So we have to multiply by the derivative of t with respect to x because all the parts of our first derivative are going to be in terms of t, but the second derivative is in terms of x. So we'll look at that here in a second. Let's go ahead and get started with number 5. So we're finding the second derivative of all of these. First, we have to find the first derivative. So the first derivative, or the derivative of x with respect to t, is 8t minus 6. And dy dt is just 10t. So dy dx is just dy dt, 10t, divided by 8t minus 6. Now we could simplify that, take out some 2's and cancel those out, but not going to yet. You'll see why in a little bit. So for this one, now we have to take the derivative of this in terms of x. We want to find what's the second derivative of y with respect to x. So that's the key right there. We're doing it with respect to x, but this is in terms of t. So like any other type of derivative where we're taking the derivative with respect to a variable other than the one that we're taking the derivative of here, we have to remember implicit differentiation, multiplying by the derivative using that chain rule. So in this case, we're going to use quotient rule. Some of you may want to rewrite it so you can just use product rule, but you'll see why in this case it's helpful to do it using quotient rule. Derivative of the top is 10, but since it's t and we're doing this in terms of x, it's 10 times dt dx. So whenever we take the derivative of t, we have to multiply by dt dx times the bottom minus the top times the derivative of the bottom. So bottom derivative is just going to be 8 times dt dx all over the denominator squared. All right, let's go ahead and take care of the numerator. We get 10 times 10 dt dx times 8t, so we get 80t times dt dx minus 60 times dt dx minus 80t dt dx all over 8t minus 6 squared. So up top, these are going to subtract and give us 0. So we're left with negative 60 dt dx all over 8t minus 6 squared. We don't want that little dt dx part in there. So think of it kind of like a fraction. If we want to get rid of it, we have to multiply by its reciprocal. What's the reciprocal of dt over dx? Dx over dt. But if we're going to do that to the top, we have to do it to the bottom. So on top, dt over dx times dx dt, those cancel each other out. Think of it like if we had 3 halves times 2/3, multiplying those reciprocals, that just gives us 1. So that gets rid of our dt dx. All we have left on top is negative 60. Well, we have dx dt on the bottom, but that is something we actually know already. If you look up here, oops, dx dt is 8t minus 6. So all we have to do is replace that dx dt with 8t minus 6. And how about that? 8t minus 6 is what we had to square over here from before. So really, we've got 8t minus 6 squared times 8t minus 6. Right? That's the dx dt. So we end up with 8t minus 6 cubed in the denominator. So that's our second derivative of y with respect to x.